Okay, I want to do a quick review of what an even function is and what an odd function is. My first example is going to be x squared. That's an even function. My second example is going to be x to the third. That's an odd function. Now, the way you test a function to see if it's even or odd is you just plug in a negative x and you see what you get. If you plug in a negative x and you get the exact same thing back, that's going to be an even function. So here's an example. We have x squared. If you plug in negative x, that's going to give you negative x times negative x, which is just positive x squared. So you're getting the same thing back. When you plug in a negative x, you get positive x squared back. That's the same thing. So that's an even function. For an odd function, when you plug in a negative x, you're going to get the same thing back, but there's going to be an extra negative. So let's look at an example of that. If I plug in negative x into x to the third, I'm going to have negative x times negative x times negative x. So that's 3 negatives. 2 of them will cancel, but there's still going to be 1 negative left. And if you bring that negative to the front, you're going to see that we do have the original thing we started with, which is x to the third. It's just that there's an extra negative in front of it. So that's an example of an odd function. Now, for definite integrals, we have a special rule for an odd function that if you go from negative a to positive a, for an odd function, you're just going to get 0. And this is important because sometimes they give us integrals that you cannot solve, but you'll notice that they're an odd function. And you'll also notice that it goes from something like maybe negative 5 to positive 5, or maybe it goes from negative 2 to positive 2. So that integral is going to equal 0. And if you look at the picture, you'll notice why. If I was doing an integral from negative pi to positive pi for the function y equals sine of x, you should notice that this area here is the same as this area there, but because this one is above the x-axis, you get a positive answer because every y value for each rectangle is going to be a positive y value. Then over here, every y value is negative, so you have the same area, but it's negative. So to be more specific, the area of this shaded region here is going to be positive 2, and the area of this shaded region down here is negative 2. When you add a negative 2 with a positive 2, you get 0. Okay, for this example, we're going to look at this odd function. This is y is equal to sine of x to the third. We do have a special rule that says sine of negative x is equal to negative sine of x. And we're going to use that rule in a second here. We do want to see if this is an odd function, so we're going to plug in a negative x and see what we get. Now this is the step where we're going to trade our sine of negative x for negative sine of x. And because it's to the third power, we have 3 of those pieces. So that means we're going to have 3 negatives. 2 of those negatives will cancel, but there'll be 1 left over. So after we plug a negative x into our function, we get the same thing that we started with, but we have an extra negative, so this is an odd function. Now the actual function is actually graphed below, so you can see what the actual function looks like. But we're going from negative 7 all the way to positive 7, so everything is going to cancel and we're just going to get 0. So the answer to this integral is going to be 0. But again, that's because we're going from negative 7 to positive 7. It has to be the exact same number, but one is positive and one is negative. And just as a reminder, this only works if you have an odd function right here. We did have an odd function. We checked it by plugging in a negative x. And after plugging in a negative x, we got the exact same thing back, but with an extra negative in front of it. So that's how we knew it was an odd function. Now, if we have an even function, there's a special rule that we can use that just makes it a little bit easier. An even function means that the right side and the left side match exactly. If we were going to do the integral from here all the way to there, what we could do is just do the integral from 0 to here and then double it, since the left side and the right side match. Now the function has to be an even function in order to do that. So we have this special rule for even integrals. If you're going from negative a to positive a for an even integral, that would be the same as just multiplying half of it by 2. So you can just do the right half and then multiply by 2, Or you could just do the integral for the left half and then double that answer as well. Either one would work. Let's do an actual example. We're going to do x to the fourth. This is the picture for x to the fourth. Now, because we're doing the integral from -2 to +2, we're allowed to use our special rule. So instead of doing the integral for both sides, we're just going to do the integral of one side and then double our answer. So we're going to do the integral from 0 to 2 and then double our answer. Now, why would we want to do that? Well, it's a lot easier to plug in a 0. That's one of the main reasons. This is an easy integral. It's going to be x to the 5 over 5. Don't forget to bring down the 2. And then we're going to evaluate it from 0 to 2, so we have to plug in the 2 first. So if you plug in the 2 first, the 2 goes here. 2 to the 5th power is 32. Then you do your minus, and then we're going to plug in our 0. So the 0 goes here. It would be 0 to the 5th power, which is 0. So this second piece actually just becomes 0. The first piece becomes 64 over 5. And there's our final answer. Now, I want to remind you that you can only do this when you have an even function. Instead of going from -2 all the way to 2, which would be from the beginning all the way to the end, we went from 0 to 2. So we went from the middle to 2. So we found this integral over here on the right. And because you would get the same value on the left side, we were able to just double our answer. And that made it easier to calculate this integral. But how do we know that this was an even function? Well, let's take a closer look. This function is x to the fourth. We're going to check it by plugging in -x for the x. So that's going to give us 4 of those negative x's multiplied together. So it's pretty obvious that there are 4 x's multiplied, so that would be x to the fourth. And because there are 4 negatives, you're going to end up with positive in the front. You don't need to put the positive. So when we plug a -x into our function, we get the exact same thing as when we plug in a positive x. We're getting x to the fourth in both situations, and that's how we knew that it was an even function.